वॉइस नहीं सही से आ रही है।
I hope the screen is visible and my voice is audible. Can somebody confirm that? Hello.
Yes, ma'am.
Okay. So, good morning, distinguished colleagues and esteemed guests. Today, we are delighted to present our research project titled LLM based chatbot for course based question answering, a collaborative endeavor by myself, Samyukta, Charumati, Darshana, and Dr. Loveland Rose, ma'am. Next slide, please. So, in the dynamic, next slide. In the dynamic landscape of education, the demand for tailored and efficient learning tools has surged. So, the current problem with the existing systems are whenever a student tries to use any LLM based tool such as ChatGPT or Bing, we get a very generic answer. The responses are not very context relevant or to the context that one is searching for. So, therefore, this project addresses the pressing need harnessing the power of advanced language models to create an intelligent system created specifically for student needs. So the key challenges that one sees when developing such a system is first one is the semantic understanding wherein the responses should be context relevant. The second one is multi-format integration wherein there are multiple materials for any student to learn from such as ppt pdfs websites and images. So a unified tool which can integrate all these formats are required and a very appealing user interface design. Next slide, please. Next slide. Hello, can you hear me?
Yes, ma'am.
Oh yeah, one second. I think there's an So the proposed solution is to have develop a chatbot which can use various textbooks, professor slides, web data, and past papers to cater to the student needs. So talking about the methodology, we have used two kinds of embeddings in this project. The first one is OpenAI embeddings, which uses the model called ADA Not Not 2 to create the embeddings from the input that we given. It has an output dimension of 1536 and therefore it is stored in a different database than the other embeddings that we'll be using. So this other not to embeddings capture intricate semantic relationships and contextual nuances within the text, enabling a deeper understanding of the input data. The embeddings generated by this model are scalable and therefore it is capable of handling both short and long sequences, making them the suitable for processing large volumes or textual data. The second kind of embeddings that we have used in this project are Hugging Face embeddings, and it uses a sentence transformer model called Mini LM L6V2, which is open source. So that's the highest advantage of this Hugging Face embeddings. And the output dimensions of the text vectors are 384, and hence it is stored in files DB, which is a database. So this encoder is primarily designed as a sentence and short paragraph encoder, and the resulting vector can be used effectively in the similarity search. Since we are using two kinds of embeddings, there are two different databases that are deployed for um, storing the vector embeddings. The first one is ChromaDB. It is an open source vector storage system, which is a vector database designed for storing and retrieving of vector embeddings. Its primary function is to store embeddings with associated metadata for subsequent use by extensive language models. It provides a lightweight wrapper around OpenAI embeddings, and hence it is used concurrently with OpenAI embeddings. The second kind of uh, vector database that we are using is FACE, which is Facebook AI Similarity Search. It is designed for efficient similarity search and clustering of dense vectors. It features algorithms capable of searching in vector sets of varying sizes, including those that may exceed a given system's RAM capacity. So this is used in association with the Hugging Face embeddings, which has a dimension of 384. And the two kinds of language models that we have used in this project are OpenAI, first GPT 3.5. We have used the free version of it to assess the quality of the responses generated, and the maximum number of output tokens that this can give is 4097 now. And the second type of language model that we have employed is the Llama 2. It is trained on 2 trillion tokens, and this is open source. We have chosen this because this can later be fine tuned with relevant data set if one comes across. So we have used this language model again. Talking about the implementation, this is the system architecture. On the first layer lies the user interface, which we have developed using Chainlit, which is a library, open source library on top of Python that can be used to develop the chatbot like interfaces. And on the middle layer lies the lang chain, which is again another module in Python that can facilitate ease of usage of large language models with Python. So from there, we have different data processing libraries. So at a given instance, one can input documents that are PDF, images, text documents, URLs of certain websites, and then PPTs, scanned PDFs, meaning the PDFs which have only images. All these things we have added in the data processing libraries. So once the data is processed, it is stored in the document store, which can be either Chroma or FICE, depends on the user preference. And the embeddings are generated and then stored. And based on the input that a user gives, a similarity search is done, and the output is given with the help of the LLM, which can be either GPT 3.5 or Llama. So now let's see a quick demo of this. I ask Charumati to present her screen. Hello. Yeah. So this is the interface of the chatbot that we have designed. So here for easy usage, first itself we have added two PDF files. Charu, can you show the settings? Yeah. So this is the setting panels where one can give in their language model, which is OpenAI or Llama 2, and then correspondingly choose their embeddings, which can be again OpenAI embeddings or Hugging Face embeddings. And the temperature is that parameter which is used to determine the randomness of the answers generated. 0 meaning a very fixed answer, and 1 meaning a different answer every time for the same question. The chunk size refers to the data that the what should the number of the size of the chunk be depending on the data that we have given. And here we'll be prompt tiles as per our requirement. So yeah, can show the processing part, Charu. So here we have uploaded two PDFs, right? A PDF file naming NLP intro and a PPT. And then based on that, we have asked one question telling like explain NLP. So this question says it also shows the sources, like which chunk the answer is from. So this is the chain of thought. So it will show the source from the original document that is used. All right. Oh yeah, scroll down a bit. Yeah. And then we have asked another question based on the second document that we have that we have given, calling the network topologies. So it again shows the source chunk from which the answer is generated. So with this acts as a unified tool which can streamline the learning process within a specified college for a specified course by making use of different study materials. So with this, any student can input whatever study material they want to, and it will generate concise chapter notes, summaries of the chapters, answers, everything with the context relevancy. So this can cater very easily to the students' needs and resolve their academic queries in a very short span of time. All right, Charu, can you go back to the PPT?
Sorry to interrupt, ma'am, but you are only left with 1 minute more.
Yeah. Yeah, next slide, the conclusion slide. Yeah. In conclusion, this chatbot offers a versatile and an accessible educational tool. There was no formal testing performed on this, which we are planning to do later on. But for now, based on the user assessment, qualitative assessment, the users were highly satisfied with the user interactions and the feedback, and it showed a high level of satisfaction. Yeah, next slide. So these are the references. Next slide. Thank you. We are now open for questions.
Thank you, Samyukta, ma'am. Now, if anyone has any queries or questions, then they may ask. Okay. Now, I would like to call Joshua D. Silva and his team for his paper presentation on the title, An Assessment of Artificial Intelligence and Machine Learning Applications in Remote Sensing for Crop Classification.
Thank you. So first we deal with the importance of large-scale crop classification. Why is this topic important? Because our world is currently experiencing what is called a polycrisis, which means that multiple different crises are converging which results in a bigger crisis. One of the main factors that contribute towards this polycrisis is the food crisis. There are 828 million people who have hunger today, which is 150 million people more than who had hunger in 2019. This increase in overall world hunger is due to both anthropogenic climate change and also due to geopolitical instability, such as the recent wars in Russia, Ukraine, Ethiopia, and in Gaza. Thus, because of this food crisis, we need to increase our food output by around 35 to 60% by 2050. However, we need to increase our food output in such a manner that we do not increase our carbon emissions. To do so is a very difficult task because the vast majority of places where we can expand our agricultural land are located in the tropics, and the destruction of tropical rainforests is extremely harmful to the Earth's biospheres. Therefore, we require careful management of the Earth's agriculture. One of the ways through which we can manage the Earth's agriculture is through large-scale crop classification, which provides